what if the latest images of an interstellar visitor revealed something that should be impossible? What if the numbers refuse to add up and the laws of physics seem to bend in real time? What if a single object from deep space suddenly behaved like nothing we've ever recorded? On November 9th, astronomers captured a new set of frames of 3I Atlas, and nothing about them feels ordinary. The images show colossal streams of material blasting outward, streams so long that they stretch across millions of kilometers. And in this video, we're going to break down what these pictures actually reveal, why the physics behind them is causing headaches for researchers, and how one specific calculation has created a problem no one can easily explain. Because according to the numbers, this object is shedding far more material than it should even possess. The jets facing the sun extend for roughly 1 million kilometers, while the ones pushing away from the sun reach almost 3 million. To visualize that, consider that the distance from Earth to the moon is about 400,000 kilometers. These streams are stretching 7 times beyond that distance, like drawing a glowing line across a chunk of the solar system. Back in July, the Hubble Space Telescope caught an earlier, softer image of the same object. All Hubble saw was a modest luminous cloud, something you might expect from a relatively quiet comet. But the new November 9th jets? They're not just bigger. They're 3,000 times larger than what Hubble recorded. A 3,000-fold increase in just a few months is so extreme that it immediately demands investigation. Normally, comets behave in a pretty predictable way. As they approach the sun, the solar wind, an intense stream of particles, pushes their dust and gas backward, forming that classic tail pointing away from the sun. Think of the solar wind as a cosmic leaf blower, blasting material off at incredible speeds. But 3I Atlas is acting like it didn't get the memo. Some of its jets are reaching toward the sun, directly against the solar wind. To hold together for 1 million kilometers in the face of that pressure, they would need to be astonishingly dense and energetic. That alone makes the images unusual. Anti-tails can form naturally, but they're rare and usually brief. We've only witnessed a handful of oddly behaving comets before. One of the most dramatic examples was Shoemaker-Levy 9. After passing too close to Jupiter in 1992, Jupiter's gravity tore it into more than 20 pieces. When those fragments slammed into the planet in 1994, each impact produced dark scars larger than Earth itself. Another strange case was Comet Holmes in 2007, which suddenly erupted in brightness and blew out a massive expanding cloud that stunned astronomers. These were natural but violent events, comets falling apart under stress. And this is likely the same category 3I Atlas falls into right now. A body that's ripping itself into multiple fragments, each fragment firing off its own plume of gas and dust. But then comes the part that forces everyone to pause. Avi Loeb calculated the amount of material that must be escaping from 3I Atlas to form jets on this scale. His result? Around 50 billion tons of mass disappearing every month. Meanwhile, tracking the object's movement through space suggests it weighs roughly 33 billion tons in total, which leads us to a ridiculous-sounding conclusion. Total mass, 33 billion tons. Material loss per month, 50 billion tons. An object should not be able to lose significantly more material than it contains. And yet, similar paradoxes have occurred before. When Shoemaker-Levy 9 broke apart, astronomers noticed that the cloud of debris held more mass than they originally estimated the comet had. The only reasonable explanation was that the comet had fractured into many pieces, rapidly exposing new surfaces to sunlight. Here's the physics behind that. When the sun heats an icy body unevenly, warm on one side, freezing on the other, it creates internal stress. That stress keeps increasing until the whole thing snaps. Once it breaks into small fragments, the total surface area skyrockets. More surface area means more ice can sublimate at once. More sublimation means more jets, more gas, more dust, more everything. If 3I Atlas is shattered into hundreds or even thousands of pieces, then each fragment's outgassing could combine into the enormous multi-million kilometer structures we're seeing in the November 8th and 9th images. Loeb's calculation would make perfect sense if the object is no longer a single solid body. But here's the catch. We don't yet know if fragmentation has actually happened. If later observations reveal that 3I Atlas is still intact, still one massive object, yet continues to produce jets of this size, then we would be dealing with something unprecedented in cometary science. It would mean a body over a mile wide with shedding mass at rates that violate what we understand about physics. A scenario like that would demand extraordinary investigation. And as if the mass loss mystery wasn't enough, 3I Atlas brings another anomaly to the table. It's traveling in a retrograde orbit. Picture looking down at our solar system from above the North Pole. Every major planet travels around the sun in a counterclockwise direction. So do nearly all asteroids and nearly all comets. But 3I Atlas? It's moving clockwise. Only a tiny fraction, maybe 1 or 2%, of objects do this, and most of them are small moons captured long after the solar system formed. Having a massive interstellar comet on a retrograde path is unexpected by itself, but it gets stranger. Its path lines up almost exactly with the ecliptic plane, the thin, flat disk where every planet circles the sun. Most interstellar objects approach from odd angles, coming in from above or below the plane. For one to arrive almost perfectly aligned with it has a probability of around 0.2%, roughly a 1 in 500 chance. If that sounds familiar, it should. Oumuamua, the first known interstellar visitor, also had bizarre traits. Odd shape, odd tumbling pattern, odd acceleration. Debate still rages about whether it was a strange natural comet or something more exotic. But Oumuamua was tiny. 3I Atlas is huge, a mile-wide object on a retrograde, perfectly aligned orbit, shedding unbelievable amounts of material and possibly breaking apart into a swarm of fragments. That combination makes it one of the most intriguing cosmic mysteries scientists have ever encountered. If you enjoyed the breakdown, be sure to stick around for more deep space updates. Nebulous Signal.